Hello everyone, welcome back to our channel Statisticians Hub. Today we will learn how to perform chi-squared goodness of fit test in R. Myself, Okram Birab Singha, a student of MSc 3rd semester, Department of Statistics, Assam University, Silchar. Now let us see why we use chi-squared test. Chi-square test is used when the value of n becomes large. It is used to test the independence of attributes, goodness of fit, and to test if the variance of a population is equal to a hypothetical value. In this video, we will learn how to test goodness of fit in R. In R, the result of the test is determined by its p-value. A p-value less than 0.05 means that the observed frequency and expected frequency differs significantly at 5% level of significance. The Carl Pearson's chi-square is given by chi-square equals to summation I goes from 1 to n oi minus ei whole square divided by ei follows a chi-square distribution with n minus 1 degrees of freedom, where oi is the observed frequency and ei is the expected frequency. Now let us see a few examples. Example 1. The demand for a particular spare part in a factory was found to vary from day to day. In a sample study, the following information was obtained. The data is given below. Test the hypothesis that the number of parts demanded does not depend on the day of the week. Now let us set up the null hypothesis. H0, the number of parts demanded does not depend on the day of the week. Against the alternative hypothesis, H1, the number of parts demanded depend on the day of the week. Under the null hypothesis, the expected frequencies of the spare part demanded on each of the 6 days would be summation of the observed frequencies divided by the total number of days, that is 6 days. Date is 1120. Now let us see the R codes for this particular problem. We type all the given observed frequencies and have given the variable name as counts. To perform the test, we need probabilities of each of the expected frequencies. We calculated the probabilities like this and we stored the value of the probabilities as in the variable props. The basic syntax for performing a chi-square test in R is very simple. We just have to write chi-square.test and then we have to put the variable name that holds the observed frequency and then p equals to variable name that holds the probability of the expected frequency under the null hypothesis. Now the output has shown like this. We have chi-square equals to 0.18036. Since there are 6 categories, so we have degrees of freedom equals to 5 and we have p equals to 0.9993. Result. Since the p-value is much greater than 0.05, so we may accept our null hypothesis at 5% level of significance and we can conclude that the number of parts demanded doesn't depend on the day of week. Now let us see the next example. Example 2. The following figures show the distribution of digits in numbers chosen at random from a telephone directory. The data are given below. Test whether the digits may be taken to occur equally frequently in the directory. Let us set up the null hypothesis. H0, the digits occur equally frequently in the directory. Against the alternative hypothesis, H1, the digits do not occur equally frequently in the directory. Under the null hypothesis, the expected frequency for each of the digits 0, 1, 2, 9 is 10,000 divided by 10 equals to 1000. Now let us see the R codes. We type all the observed frequencies and stored in the variable counts. Again, just like the previous example, we calculated all the probabilities of the expected frequencies and stored in the variable props to perform chi-square test. Now we type chi-square.test and we put the variable counts and then we type p equals to props. Now the output is showing like this. We have chi-square equals to 58.542. Since there are 10 observations, so we have degrees of freedom equals to 9. Here the p-value is very small, so we can reject our null hypothesis. Result. Since the p-value is much smaller than 0.05, so we reject our null hypothesis at 5% level of significance and conclude that the digits are not uniformly distributed in the directory. Now let us see the next example, which is a little bit different from the previous two examples. Example 3. A simple analysis of examination results of 200 MBS was made. It was found that 46 students had failed, 68 secured a third division, 62 secured a second division, and the rest were placed into first division. Are these figures commensurate with the general examination result, which is in the ratio of 4:3:2:1 for various categories respectively? Now let us set up a null hypothesis. H naught, given data commensurate with the general examination result, against the alternative hypothesis H1, given data doesn't commensurate with the general examination result. Under the null hypothesis, the expected frequencies would be 4 divided by 10 into 200 equals to 80 for failed category. Similarly, we calculated the other expected frequencies. Next, we type the R codes like the previous two examples by storing the observed frequencies to the variable counts and the probabilities to the variable props. Then we perform chi-square test using this syntax. Now the output is showing like this. We have degrees of freedom equals to 3 and the p-value is very small, so we can reject our null hypothesis. Now let us see the result. Since the p-value is much smaller than 0.05, so we reject our null hypothesis at 5% level of significance and conclude that the data are not commensurate with the general examination result. Here ends my presentation. If you like this video, give a big thumbs up and do subscribe our channel Statisticians Hub for more such informative video updates. Thanks for watching. See you in the next video. Bye.